Hello, my fellow YouTubers. This is Roy back. Tonight we're going into capacitance. And I got some good little cookies I can share with everybody on something I realized that I didn't realize, and you guys may or may not have realized when it comes to capacitance. It has a place in its dielectric world where it's multiplied. And that's where this video is going to go. So hang on one second. Let's just build up a couple peeps. And we're going to get into that capacitor, the one I have up there, and that other one there. Right there, and the one in the back, and we're going to show a mirror image of each one based off of, I have a voltage multiplier right here. It's simple. It's AC in. So AC is coming in on which the AC is the PMH. So AC coming in, going out, it's a voltage multiplier, and it just steps it up twice the voltage. But the cool thing is this cap and that cap keeps its voltage. So as we work through where it comes out of that into a capacitor, and then how we could share and add the voltage of this equation there, of this voltage doubler, based on what I have feeding it. This will give that and will give that the same voltage. And if you keep, hey, Tommy, bingo. All right. And if you can ricochet it, and it reminds me of something special. It reminds me of if you were in a hallway and you were looking down the hallway, and you had a mirror behind your head and in front of your head, and you're looking in the mirror in front of you, and you see yourself continuously traveling. That's what we're talking about tonight in tonight's video with capacitance and mirror image. Now, the mirror image is what I just said, is that it continues to go on and on and on and on and on. And that on and on and on, to me, reminds me of each solar system in our universe. And the solar system is just a repeated step. It's almost like something that reminds me of passive meditation and dynamic meditation. Leave your comments if you know what either one of those are. Passive meditation and dynamic meditation. And that's what we're talking about also with capacitance and dielectric. And then the space outside the dielectric becomes the medium. The medium becomes the place that we have right here. That this is our medium. It's how Mother Nature transforms now. So it's pretty cool stuff. So let's give me 1 minute. I'm going to get everything together. I got collect some things, some batteries and stuff. And I have some cool stuff getting ready to start on my next couple of videos. I have a magnetic relay here, which will handle whatever voltage I can come out, so I can get my driver going. I'm still working on, obviously, no reed switch can handle what we have going here with the strength of the magnets. So especially when they're getting dumped into like a tank circuit. So to me, let me explain to you guys. To me, what I'm creating here is a variable tank circuit. Meaning variable, it's not always the same coil. It's the group of coils that's in front of the PMH would be the tank circuit to the capacitor that's sitting on top there. So the capacitor up top, which I will have connected to the one below in the ground, high static, very much high inductance on the two, just the two, not all, because we're talking about being there you go, Tommy. So we are talking just how Mother Nature reacts to how the ground shows us with the clouds. Mother Nature there shows us the ground reacts. So the only way I can think of to tap into the ground would be electrostatically. Just so much makes sense. I will watch that video. So much makes sense. So you got your capacitance up top that's going to go down to the inductor. So you'll have your tank circuit switching. And this capacitance here seems to be like I could spread it out just from what I just kind of realized on working on these capacitance. I guess I got a couple people on. I can get going a little bit here now. Show some. Give me 1 second. We'll go ahead and we'll start a little test. The first test we'll do will be we're going to work through the circuitry and we're going to show where the storage of energy is going. Okay. First, we're going to clear it out so there's zero storage. And then we're going to start to spin the wheel, build storage, and we're going to look at what compartments in the array set up is holding what storage, and see if they all balance to be the same storage, or is one of them multiplying as we go. Now, this is how I know this is going to start working. And the fact that I realized it today on putting several capacitors in place, and as soon as I started doing some tests with them, all of a sudden, I just learned something that probably somebody educated knows already when it comes to electrical engineering, but they're not thinking in their mindset of what I'm working on. So there you go. It's like, have the knowledge here because you're trained is cool, is the best, but here you are as a garage guy, and you just happen to have to turn the corner and find that. To me, that's a major, 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 major. So I'm going to take you off here. Let's start through the process. With this voltmeter, the voltmeter is on 0. Why is it on 0? It shouldn't be on 0. But I guess we can see what it's hooked up to first. This guy. All right, so I have 2 of these. And this right here is 1,600 volts. That's a lot of volts, guys. These are oil cans. These are resistors that are oil cans. They call them, they got oil in them, so they got a really good capacitance about them. 1,600 volt, and you got 4.7 microfarads. That is some good storage right there, is all I'm saying. So why I want to talk about storage and capacitance is because, you know, you got to search for it, and it really makes sense in what I'm working on to kind of explore it deeply. So I have a long time ago, but now I'm bringing the surface back up. So it's sort of like everything I read or do sort of goes on a shelf, and it's there in your mind, but if you ever need to recall it, you can dig back into it. So here we are. We're pulling shit off the shelf tonight. So tonight the capacitance is going to come in play with all this whole array. And the capacitance, we're going to start off with a couple of different tests, and we're going to kind of like prove a couple of different things that I think that come into play with Ed Leedskalnin. So let's start off with how this is ran. Sorry I don't have it drawn out, but it's like, here's your PMH, all right? PMH means 2 coils and a U-shaped bar, iron bar. So you have iron bar here and iron bar here. Usually I use this one to start. This is the one I always am looking at first, I'm closer to. So this is like the one I set up. So when I wound these coils, this and this one are wound the same. Now check this out, because this is what you should know if you're dealing with stuff like this, is that even though it was wound the same, you can flip one over and still accomplish the same goal by having a north or south always come out of here when you're putting a positive or negative in the same place all the time. So follow me now. So what I did was the start of this guy and the start of this guy is on that side. So basically these two should be on this side matched up, but they're not, because I had to make this one a south pole, this one a north pole. Now this one here I wound the second time, and what I realized was that the counter that I used is how I wound my coil. I realized you could do it backwards, but what you have to do is wind up all to your, like for instance, 1500 turns. So I'd have to wind at 1500 turns, then I can rewind it 1500 turns, and then it's good. But you can't start from zero and rewind it for some reason. So maybe something I don't know that I'm doing wrong, but that's all I know. So on this setup here, I overcame the first problem. The second ones I made are wound the opposite way. So one's going clockwise, which is this one, which is north at this end, and this one's going counterclockwise, and this is south on this end. So right now I have the start of this connected to the start of that one, okay? And then coming out of the end of that one, and it goes to one side of the multiplier. Now this over here, the other side that doesn't run that way, which is connected, which is the two outs, right? So you got your start, remember I said? Your two starts goes that way. And then your out over here, both outs on here go to the other side of the bridge rectifier. If you want to look at the bridge rectifier, how I have it set up, I have a capacitor, so I'm coming in one side, and the side I'm coming into is the, see here, give you the right information. It's the negative side of the electrolytic capacitor. Then on the right side, we're coming out, we're going into two diodes. One's heading in with the ring into that capacitor, and the other one's heading out. One heading in is coming from, connect to the negative rail, and then the other side you connect to the positive rail. Okay, so you get a charge in this sucker. So whatever's showing up here is showing up here. Whatever's showing up in here is showing up here. Whatever's showing up here is showing up here. Whatever's showing up here is showing up here. Whatever's showing up here is showing up here. So you start to see your mirror image of how it works its way with a voltage. Now, there's a lot more to this, because you not only got your voltage, but you got your pressure to deal with. When you deal with pressure, you're building a wall of resistance when you deal with pressure in an environment. So you have to overcome that. So we're going to work through this, because today is a good day. Today is a really beautiful day. And we're going to work through this, because I can see it. I see it. Once you see something like being in class, once you see something in class, you got it, Tommy. Wow, wow, wow. Once you see something in class and you get it, reminds me, ninth grade, high school, didn't do good in English class. All of a sudden, one day I got it, bam, knew everything about valves, verbs, nouns, pronouns, just flying through stuff that I was all oblivious to. So here we go. So let's make sure this voltmeter, see what it's connected to. So you got the connections over there. Now you come out of that, you're into the multiplier. Now this multiplier can be multiplied. Now, haven't even ventured into the multiplication of coming out of here yet into our array, which is going to happen. You know why? because the more volts, the more current, the more amperage that follows the volts. So you want to build up the volts. So we can already see from the stuff that I've been doing that our iron is absorbing so much that the voltage is getting washed away. So you need to increase the voltage. So that was part one, why I made 2 PMHs out of 22 gauge wire, 1,500 turns each, and not done it out of 16 gauge wire or 18 gauge wire or 20 gauge wire, or even 24 or 26 gauge wire, because you start strangle holding the current. Now the current that I need is what? So the stuff that's coming out of these guys is the energy we're talking about. So we don't want to strangle hold that. So basically, as I grow into this, eventually these will be 16 gauge wires. Why? Because I will already had figured out the compression and the decompression places of the system that allow these to be 16 and allow eventually that current to come through. Right now they're 22 gauge, so they're kind of stranglehold, but this is what we have. So we're going to start off right now, and we go to this capacitor here. So this capacitor is on 0, and everything's on 0. So and that means these capacitors are zeroed out too. So let's go ahead and turn the wheel. Let's see what comes on. So we have nothing. So that means this guy's still hooked up. So let's undo that. So that has a charge up there, by the way. This is the mirror image. See, a shock just came from here. So you have a charge that's here, just transferred here. Now it showed up here, which is what? 32 volts, okay? Didn't turn the wheel that fast, did I? So 32 volts are sitting here. So here you go. This capacitor is sitting with 32 volts. Now let's pull the voltmeter off of this, which is this guy. This was the first one, right? Let's get this on the right pole. This is the first one. Don't want that one. We want this one. This was the first one. So this should be sitting. All right. So right now we're at 0 volts, right? So I'm going to take this, connect it. And let's see what we're sitting there. We're at 32 volts. So we expanded the 32 volts, not to be all stupidly, it's a pressure thing. All that power was sitting there and just wanted to come in here because of the lack of maybe the knowledge that I have, or just the ability to understand the pressures. So the pressure of this wheel turning at a certain speed would only build up a certain pressure in the capacitor or capacitor or capacitor or capacitor, or so on, so on, so on, that 32 volts will still travel and travel. So basically now there's 32 volts in this guy, 32 volts in here, 30 volts in here, 32 volts in here, and so on. So you have like a layer. This is going to be the part that really got me here now. So we're not turning the wheel, and we have everything filled. Now follow me here. This is the shit right here. So right now this voltmeter is connected to this guy right here. So let's dead short that, okay? We're going to dead short it, all right? And we're going to the voltmeter should drop. Oh yeah, you see that? Hold on. The dead short in that. Look at all the stuff that's in there. That's some good ass stuff that just came out. So now we're down to 11 volts. I can't even get the some bitch up still. It's a lot of dropping it down. All right, so look, I got it down. That's connected to there. So the wheel's not turning. Now here's your multiplication of the mirror image of the capacitance, which is the dielectric, which I'm claiming that's in between every solar system. There's a dielectric, so it continues. It's a mirror image of everything. So here's now, we know we have 32 volts in here. Look, so it built up a little back up, 2.3 volts. How it's still climbing, I don't know. We didn't get all the juice out. Let's go a little deeper on it. Let's do another smackdown. All right, so we're draining it the best we can. Yes. All right, so we're drained. So now let's go ahead, and this is the amazing thing. So let's take the capacitance that's in here, which, let's check the voltage. That's how we're going to do this, so you guys see it. So this is the voltmeter. We connect the positive here. Negative here. Voltmeter's up to 31.7 volts. So let's go back up here and connect this capacitor. And we're at a volt. Okay, so we can clear that out. Let's clear that out. All right, so now we're going to go ahead and come out of this capacitor and grab two fresh leads. I love these guys. I can't wait to dig into them. I've been so busy. I'm getting ready to remodel my bathrooms. So be on top of what I do for work. It's like crazy busy. All right, so we're going to come out of this side here, and we're going to touch that side, and then we're going to come out of this side. It wants to stay. And we got that. All right, so this is the thing. So we got 0 point nothing on the voltmeter. So the voltage we knew here was what? 31 volts. So, and change. So we're just going to tap. That's it. Just that one tap, all right? One tap. Let's go down to here and see what we have. 7.95. That shouldn't be either. What's going on here? So let's go ahead and check the voltmeter from, where is this? Let's see. All right, the out. So the out there's 5. The out to that needs to come off. And then the out to that is off. And we've got 8.2 volts. Yo, I'm in the house. That's my boy. Let's go ahead and charge up something here. So we're not charging because we're coming out of the multiplier. Where are we going? We're going to this. And we got no voltmeter hooked up to it. So let's get the voltmeter. This is 7 volts. Come over this side. And then the other side of the voltmeter comes to this side. And then what's coming out of here? That goes to the charging. All right, so we're charging this one. So we got 17 volts. So I didn't even really, what the hell just happened? I'm barely even turning. So that was the key. Is let's drain this one out again. Let's go back and drain this. So we're going to zero it out, the capacitance on this first capacitor. And notice I don't have to turn the wheel a lot. So there's not a lot of pressure in this capacitor. So I'm going to just turn the wheel a little bit, and we're going to watch the volts go up. 4, 9, 5 volts. Now, you can see the wheel is starting to slow down on its own. So the voltage will stay at whatever its peak is on its switching. So it's switching changing its poles created a pressure of a wave. You follow me? Follow my finger. There's a wave going. So that wave created a pressure. We got 4.6 volts. Now, if we transfer that voltage upward to another capacitor, or to start off with, this capacitor, it's got 4.6 volts. What did I miss? Where's everybody at? What happened? What happened, everybody? Jesus, man. All of a sudden, everybody dropped off. Everything disappeared. Holy moly. Give me a comment. Anybody out there? Should I turn it off? I think the magnets on the wheel just disturb everything. Tommy's back. All right, Tom. So, I don't know what just happened, but hey, exhibits. I don't know what just happened, but I think from turning the wheel, I got too close, and pretty much everything went downhill from there. So, on the voltmeter, I got 34. Brandon. All right, so I'm going to back up a little bit here, and then I'm going to give the wheel a good spin. And we're at 34. Let's bang on the 34 volts. All right, right there. You guys can see that 34.0 volts. Yeah, that's it on this capacitor, and that's also. All right, let me get it off back in my hand. So this capacitor has 34 volts. That has 34 volts. This one has 34 volts, or 33.4, whatever that says. So now we're going to go ahead and take this one here, and we're going to go ahead and discharge it. So let me disconnect the feed from that one, and I believe that one. So it's 0 there. So now we're going to go ahead and we're going to take the voltmeter, and we're going to go ahead and connect to the leads that I just took off. We're going to show that the voltage is staying from down here in the multiplier, and then it's continuing up to and through each capacitor.